Hey PC World fans, Adam here with the review of the Intel Core i9-14900K. But I'm not alone. I'm with Brad Shoemaker from Nextlander fame.
True. Hello.
Brad, are you excited to see the magic that 14th gen
Sure.
brings?
Excited, interested, curious, intrigued.
Okay.
Some
all right.
combination there.
Well, just so you know, he has literally not seen any of these numbers. He's coming in fresh, so he's going to have some hopefully some good questions, some good reactions to the information that we're going to have here. But I think the first thing we need to talk about before we get to the numbers is where's Gordon? And why am I the one doing the CPU review? So if you haven't seen the recent news, we talked about this on the Full Nerd from a couple weeks ago. Gordon is on medical leave, and I'm not going to get into the details here. Go watch that interview. But I decided to step in and fulfill this CPU review role. I felt it was important to me to continue Gordon's awesome work, and even though he's on medical leave with these new CPUs launching, I thought now's as good a time as ever to try my hand at it. And luckily, I have a lot of insight into the testing Gordon's been doing for years. And even more so, Gordon, even though he's on medical leave, he has been actually helping me for the past number of weeks, set everything up, configure it, double check the numbers. He even made some of these charts. So Gordon has been involved in the CPU review. I definitely couldn't have done it without him.
The man has opinions about central processing units, and he cannot contain them.
He does. He loves this stuff. So I'm glad to be able to fill in for him and kind of continue this going forward. Also, at the same time, I did get some help from friend of the show, Steve Burke from Great Gamers Nexus. I consulted him a lot. I even pinged Dr. Ian Cuttress from Tech Potato a couple times with some really stupid questions, and he was very nice about it. So this is my first time benchmarking a CPU. And I'm actually going to talk about this in the Full Nerd that we're going to have later today. So definitely go watch it. Because I definitely want to get into what it was like testing my first CPU, because it was harrowing in different ways than I expected. But all in all, thank you to Gordon. Thank you to everybody who's helped out. Thanks for Brad for coming in and doing this video with me. Also, I do want to thank some of the vendors when I reached out to Intel and AMD and told them that I was going to be filling in for this the CPU review. They were both awesome. And definitely sent me a bunch of samples and made sure I had everything I needed for new test benches. And then also companies like Silverstone and Patriot donated some gear for the actual test benches. So thank you to them. I really appreciate it. But yeah, with that, let's go over the configuration of those test benches. So for the hardware used, I threw everything into a Corsair 4000D Airflow, but had all the panels off. It wasn't a fully open test bench, but I mean close enough. Inside, both of them had an MSI GeForce RTX 4090 Gaming X Trio cards. Both of the systems were cooled with a Corsair H150i Elite 360mm AIOs. Patriot hooked me up with some Viper Venom RGB DDR5 6000 mega transfers per second. I had two crucial 2TB T700 Gen 5 NVMe SSDs. Gen 5, yeah, we'll talk about that in a second though. And then Silverstone provided two identical Hella 1300R Platinums to power both of these systems. So let's talk about what's different. And obviously, other than the CPUs, it was the motherboards. So Intel provided an ASRock X670E Tai-Chi motherboard to use for the AMD system, and Gigabyte provided one of their refresh boards, the Z790 Pro X. That motherboard I'm going to talk about on the Full Nerd, because I actually really like that motherboard. Not just the looks, but also the updated UEFI. Pretty good board.
Since it is pretty much a continuation of last year's chip, how different are the motherboards and the chipsets? Are we still just doing Z790? Is it Z790 Plus? Are the boards much different?
Z790 refresh.
Okay.
So every motherboard manufacturer has announced some sort of refresh board, so it really depends on the motherboard and kind of the line. So there are new features. There's definitely new reasons to look at motherboards for sure. But anything like PCIe lanes, chipset stuff, it's the exact same.
Okay.
Which also means that if you have another chip, but you actually want to use an older chip and put it in one of those refresh boards, you can use it. It's the same socket, Literally nothing has changed.
3 years of the same socket on Intel.
3 years the same socket, yeah.
Pigs are flying.
Right. So these, talking about the actual CPUs themselves, good question. These are literally just refresh, Raptor Lake refresh. So across the stack, they've got clock bumps. The i7, which I will have a review of. I've almost done with the testing, just not in time for embargo, unfortunately. The i7 does have extra E-cores, but other than that, it's essentially just more of the same. Pricing's adjusted just a little bit, but nothing major. So yeah, unfortunately, not really much to talk about. If you're already familiar with Raptor Lake, this is just a refresh of that. So let's go into the software configuration. So Gordon and I talked a lot about how to actually configure the systems in terms of PL1, PL2, power profiles, MCE, PBO, things like that. So it kind of goes both ways. I know some reviewers definitely like to go in and manually set things, especially like PL1, PL2. Some of them like to turn some of those features like PBO off, MCE off, things like that. But actually the way that we have it configured here is kind of, and you'll see this with a lot of the testing too that we did. We were like, hey, you know what? If you're going to turn it on and you're going to throw in a $600 CPU, you're probably going to have adequate cooling. Hopefully, you should have adequate cooling. And you know what? Just let the motherboard rip. Just turn everything on, let it auto everything, and kind of push it to the limit. So yeah, everything was set to auto, kind of the way that the motherboard intended. So yes, you probably will get different results based off of the motherboard choices, but these are the motherboards we're using, and we like doing it that way rather than going in and kind of manually configuring everything and trying to take that variable out of it. Because I mean, at the end of the day, it is kind of not just the CPU, it is also how the motherboard is going to play. But both of them were from the highest end chipset, Z790, X670E, so it's not like I was pairing a low-end motherboard with a high-end motherboard or anything like that. So just for those who are wondering, the Z790 BIOS version was F3, and the X670E BIOS version was 1.29.AS01. So got it. Just in case you're wondering. And inside of Windows, we kind of went back and forth on this a little bit too, but VBS was turned off. The only reason why I kind of messed with that, in a lot of ways, like I said, I wanted to kind of just have things be configured out of the box, is that actually when I loaded up one system, I believe it was the Intel system, had VBS default to on in the OS install. It was a clean install. The AMD clean install actually defaulted to VBS off. So I was like, okay, well, I gotta, they need to be in parity. So we decided to just turn both off and go from there. Both of them were set to the extreme power profiles within Windows. Obviously paused any updates, things like that. I actually did uninstall some of the things that would run in the background, like OneDrive or Teams, things like that. But it's mostly just a Windows install. So before we get to the numbers, I know this is a little long, there was actually one stumbling block that I did run into in setting up and configuring these systems, and that was those Gen 5 drives.
Interesting.
When Gordon and I sat down and I was like, hey, should I go with Gen 4 drives or Gen 5 drives? And he's like, you could really use either, but might as well move to the newest thing. And I was like, okay, I'm down. So I wholeheartedly wanted to go in using those Gen 5 drives. Not that it's really going to matter for performance, but setting up new benches might as well. Unfortunately, this Z790 board, when I plopped the Gen 5 drive in that top slot and then put in a GPU, and I was going through all my testing configuration stuff, I realized that the GPU was running in by 8 mode instead of by 16. Mm-hmm. I was like, wait, why is that? And then of course I had to go to the manual, and when you populate that top slot with Gen 5 drive, that first PCI slot goes into by 8 mode, and I was like, oh,
it's the peril of PCI Express.
Yeah. So I mean, honestly, yeah. What I thought about trying to do new installs, but instead actually what I end up doing is going into the BIOS of both the boards and running those Gen 5 drives at Gen 4 speeds. So essentially these are Gen 4 drives in here performance-wise. I did double check them with Crystal Diskmark, do some tests, so it's just running at Gen 4 speed. All right, with all that out of the way, let's get to the numbers. Are you excited?
Let's see some numbers.
All right. Well,
how different are they?
Well, we're going to start off with rendering. That's
Okay.
the place that Gordon likes to do it. And we are going to start off with Cinebench R23 single thread. So the way that we like to do it for our testing here is that we do a 10-minute loop. And for single thread, it actually takes a number of minutes to finish one loop, which means that at the 10 minutes, it lets the previous loop finish. It's not like right at 10 minutes, it just cuts it off. It actually will finish the loop. So sometimes it goes a little bit longer on the single threaded run. But then also at the same time, we do 3 loops back to back. So some people like to, kind of let it normalize before another one, but I actually wanted to stress it a little bit further. 3 loops back to back, did the average. That's how I got the numbers on all these. So anyway, Cinebench R23 single threaded. And as you can see, the clear winner is the 14900K with a whopping score of 2230. Mm-hmm. That is at least, not quite 100 points faster than the 13900K. But hey, what Gordon would say is bigger bar better.
Sure.
Right? And
can't argue with that logic.
So obviously comparing it to the 13900K, on the AMD side, I have the 7950X and the 7950X3D. Those AMD ones in single threaded are you could call it dead last, but guess what? It's not really that far off. This really translates to clock speeds, and what you're seeing is because there's a 200 megahertz increase on that 14900K. It's just going to turn in a little bit better of a single threaded. So moving on to multi-threaded workloads, we got Cinebench R23 multi-threaded, same thing, 10-minute loop, 3 back-to-back runs. And this is the average number of it. And we can see, wait, hold on. There's not really much of an improvement. This is just within margin of error between the 2 Core i9 chips, and that's because the actual power profiles have not really changed much. For the 14th gen, they have enabled a new extreme power profile, which we'll talk about in a little bit, which doesn't actually change the PL1, PL2, which is still what they recommend at 253 watts, but it's really up to the motherboard manufacturer. But they have changed the ICC max from 307 amps to 400 amps on that extreme power profile. So we'll talk about that a little bit later. This is not running the extreme. This is just running the performance power profile, or I should say what Gigabyte called in their board the optimization. Once again, it's auto, but it's running essentially at this, and it could do the same thing with 13900K. We're not getting any benefit. And then those big cores on the Ryzen 9 non-X3D part are able to keep up, and of course on the X3D part, one of those CCDs has the stacked Vcache on top, so it's going to run a little bit slower, and it's just going to turn in a little worse of a score on that one. As somebody who actually uses a 7950X3D part in daily use, have you worried too much about multi-threaded workloads like this?
Not so much. I'll leave Resource Monitor open occasionally and watch, is it parking the other die? Yes, no, but it really just feels like a 16-core chip, honestly. Granted, I'm not running Cinebench or doing intensive benchmarks or even rendering real-world 3D scenes or anything like that. I'm encoding video and audio here and there and some stuff like that, or compiling software in WSL2 once in a while. But
Nice.
Long story short, I'll pull up Task Manager and just look at the 16 cores, the 32 threads, and they all just kind of are CPU cores, and I don't really think too much about which one has the Vcache, which one is running at a higher or lower clock speed. So
Nice.
obviously, if you're in this world where these sorts of numbers matter, it's maybe not the ideal productivity chip for pure number crunching.
But still, it's not that far off. Honestly, sure, it's at a deficit compared to the other 3 chips, but it's still within the ballpark.
Yes.
So now let's move over to another rendering workload. This one is Blender 3.6.0. It actually has 3 different scenes that it renders in the background: Monster, Junk Shop, and Classroom. So in Blender, AMD obviously has an advantage, and even that X3D part, although it was slower than the non-X3D part, is still performing better than both the 13th gen and the 14th gen chip in every single one of these scenes. So AMD definitely has an advantage in Blender. Once again, it really depends on the application. That's why a lot of times in these CPU reviews we will definitely stress like, hey, look at the actual workload that you're doing and kind of how it performs in there, because that really is going to make a difference. The same thing happens over on V-Ray, and once again AMD has an advantage. Even that X3D part is still better than both of the other i9s, and the i9s are dead even. I mean, but these once again are very multi-threaded intensive workloads.
Sure.
So don't expect oh man, all of a sudden my multi-core performance on 14 gen is just going to be so much better. Even in the extreme power profile, which I'll show later, it's not really that much better. You're able to get as much as you can out of that 13900K.
It's still P cores and E cores, right? Like AMD is just going to benefit from having 16 full fat cores as opposed to the mix of big and little.
Yeah, well, and once again though, it does depend on the benchmark.
Sure.
So we're going to switch over to some content creation stuff.
Okay.
And this time we have Handbrake 1.6.1. This was transcoding a 4K video. If you want to know the actual transcoding settings that I used for Handbrake, look in the description, because I'm not going to go over all of it here, all the different flags. But Handbrake benefits Intel. Something about the way the encoder works in there just benefits Intel. Once again, it's just so application specific. You just need to know, I should say, shorter bar better here.
Yes.
And these are measured in seconds. So both Intel chips were able to encode this a little bit quicker than the actual Ryzen chips. I mean, not a ton quicker. We're talking about less than a minute between them, but still, hey, shorter bar better. In this case. Another content creation one near dear to my heart is Premiere Pro from Adobe. A couple things on this one. First one is I'm using the newest version of Premiere Pro. I'm also using the newest version of Puget Bench. Puget Bench for Premiere Pro has actually made a major change recently. I've been meaning to do a video with Gordon about this because it's kind of a big deal, and they've taken out the actual test inside of Puget Bench that did any sort of real-time playback stuff, which for a video editor like me, I've actually care more about playback speed and going around and editing the video than actual encoding speed, which is kind of different than Gordon. Gordon just likes seeing things in code and all the stuff light up. So I'm a little bummed that they actually took that out. And for those who have watched our past videos know that Intel had a huge advantage in Premiere Pro, specifically because Premiere was able to use the IGP. AMD, yes, does have an integrated GPU, but it is not activated and used in any way in Premiere Pro. So you would just see this huge uplift in especially the real-time playback and scrubbing. So this is not in this new test, and you can't go back and compare this to the old test. Actually, if I had time, I actually wanted to go back and run the old version of Puget Bench, but I decided to run the newest one. Anyway, for the most part, if you look at the overall, yes, you see a clear advantage to Intel, but if you look at the subscores in here, it only comes from one place, and that is LongGOP. Brad, are you familiar with the difference between LongGOP and IntraFrame?
Is that group of pictures? Is that what the?
I actually I don't know what it stands for, but no, it probably does. Yeah,
Okay.
yeah. So
Something about keyframes, I'm guessing.
so it's the compression. So IntraFrame is going to compress each frame individually,
Sure.
which leads to larger file sizes.
Yes.
LongGOP is actually takes compression out of chunks of video. So
Like delta compression between frames.
yeah,
Yes.
exactly. So and it really depends per camera, manufacturer, what kind of codec you use, things like that. But generally, to be able to decompress it inside of Premiere Pro, it takes a lot more CPU utilization to do that with LongGOP. But the added benefit that you get smaller file sizes. We actually use LongGOP on our video shoots here. So looking at that number, Intel definitely has an advantage in LongGOP. And what that comes down to, I actually don't know. I would love to talk to the people at Puget Bench to know exactly what's going on here. I didn't have a chance to really dig into okay, well, is it able to take advantage of the IGP maybe in this specific scenario, or maybe just the fact that it's got more cores, even though not all of them are big cores. I'm not quite sure, but either way, this is another one of those situations where I say, hey, if you're deciding between AMD or Intel, you got to kind of look at the workload. If you shoot in long op, then yeah, maybe you should look at Intel. But if you're not, if you're shooting in RAW, then whatever looks pretty much like a wash.
Yeah.
So moving over to another Adobe application, we have Lightroom Classic. I will say that it does have subscores for both active and passive. Active means moving around, editing in the develop panel. Passive is taking all of those photos and exporting them. Intel has a little bit of an advantage, but it's not a ton. And speaking of more photo editing, we got Photoshop 24 with Puget Bench. We have the overall score, still once again favors Intel. And if we look down at the subscores, no one thing is like giving them an advantage. It's just kind of incremental advantages in each one.
Sure, but it really does manifest in the overall pretty significantly.
It does, and once again, I think when I get to the review of the i7 and even the i5, what it's going to show is that Photoshop is not really that CPU intensive anyway, really. It's not like Premiere. So like the scores, yes, you're seeing an advantage for Intel, but I don't think this is like anything you're going to appreciably feel
Sure.
For Photoshop use. Maybe if they add more stuff in Puget Bench, that deals with the AI neural filters, things like that to like really stress it, then maybe you'll start to see some differences. But for the most part, I don't see huge changes in these numbers. Now we're going to move over to some general productivity benchmarks. This first one up is Crossmark, which they describe as a real-world application performance benchmark.
Okay, this is one I haven't heard of before.
Yeah, so there's a couple of them out there. This is by Babco. The other popular one is UL Procyon. They used to have PC Mark 10. I didn't get a chance to use Procyon. I wanted to because it measured a lot of application performance as well. PC Mark 10, I actually did run some PC Mark 10 stuff, but it's a little older and kind of end of life. And that one uses open source applications to kind of get some real world application stuff. Does this really actually translate to real world? I don't know. That's a debate that that people can have. But either way, for Crossmark, it's showing a clear advantage to Intel, and especially when you look at creativity and responsiveness. So each of those subcategories, productivity, creativity, and responsiveness, have different applications that they're running to try to do different things. You can go look on the website and kind of see the breakdown, but creativity is definitely going to favor more cores. Responsiveness is definitely going to favor higher clock speeds. So, they just kind of jam it all up into an overall score. And does this mean anything?
Well,
maybe.
I have to remind myself not to just stare at the top 10% of the graph here, because in the grand scheme, when you look at the scale, it's not a huge difference, but there is more of a difference between 13th and 14th gen here than on a lot of these. That's
for sure. Yeah.
There's a gulf here compared to some of these. Compared to where it lost 10 points from last year.
Yeah.
This is at least a more pronounced increase on the new chip.
Yeah. This isn't just run-to-run variance or
Yes.
That kind of stuff like that. But I really think here it obviously comes down to just that clock speed bump. And hey, when you're mousing around and you're doing some basic stuff, that responsiveness is a big deal, and clock speed definitely is tied to that.
Arguably the biggest deal, I think, actually in day-to-day use.
Right.
If it takes a fifth of a second longer to open File Explorer or something like that.
And in the course
feel
of
that.
in the course of setting things up and making sure my configurations were correct, this 14900K was hitting 6 gigahertz, no problem. Boost, it boost-ish, right? It was mostly 5.8, but if it needed to, it would boost up to 6 gigahertz, no problem. And this is not any special overclocking or anything. Definitely more snappy. Does that mean that the 7950X3D is less snappy? Do you feel like your chip is slow?
Well, coming from a 7-year-old machine, anything was going to feel very fast.
Right,
but
right.
No, it is quite usable, let's say.
Yeah. So moving over to Web Expert. and looking at that this was running Google Chrome, Gordon wanted me to actually denote which version of Chrome, but when I went in to get the number, it updated, so I actually don't know. So
Chrome will do that.
Chrome updates all the damn time, so it's kind of hard to track down. Either way, once again, a little bit of a snappy advantage to the Core i9s, but do you actually feel it? You know, I don't know. I think you would really have to sit down and like feel between the two. But it is at least good to know to run the test and see if there's anything where like it was like, oh wow, that doesn't make any sense at all. Like, why is it having that bad performance? So, and then another one we can throw away real quick is Geekbench 6.2.1. Gordon would like to call this the official benchmark of Twitter arguments TM.
Mm-hmm.
I don't really care about Geekbench, to tell you the truth, but you know, Gordon loves running it, so I ran it for him. And in single core performance, look at that. 14900K on top. Bigger bar better. Intel wins in single core and in multi-core. You see a bump on both of them. Yeah, Geekbench, whatever. You know.
The people demand it.
I guess, you know, like if you're really wanting to get on Twitter and argue about Geekbench scores of Apple versus Intel or something like that, then
If you really
be
want
my
to
guest.
get on Twitter and yell at people about their chosen product versus your chosen product, go with God.
Go with God, right? Speaking about arguing about products, let's get into the gaming section. I think that's going to be interesting to you.
Fertile ground for warfare between graphics cards, consoles, anyway.
Right.
Yes.
So I didn't run a ton of game testing. I'll say this up front. There's a lot of people who are going to have videos on the embargo that are running a lot of game stuff. So definitely go watch, you know, Steve at Gamers Nexus, or Hardware Unboxed. I'm sure they're going to have some awesome testing. So I didn't get too much in the gaming stuff, but I did want to run just kind of some games and some different configurations and just kind of test things out and make sure there's nothing super wrong with it. But to tell you the truth, the landscape looks exactly like it did when the X3D parts come out, and it's of course exemplified with Shadow of the Tomb Raider here. This was running at 1080p, the highest preset. No ray tracing, no upscaling, and this is average frames per second. Yes, the 14900K with the little bit of boost did better than 13th gen, but it was not enough to catch up to the 3D Vcache part. Shadow of the Tomb Raider loves that Vcache.
Sure. And this is where I start to feel vindicated after 12 successive benchmarks with that chip at the bottom. It's like, oh, right, this is why I got that chip. But like, it seems like the real story here is just looking at the two generations of Intel, even in a CPU-bound scenario at 1080p like this, basically no difference.
Basically, right? You know what I mean? This is run-to-run variance for the most part. And I mean, the 7950X is no slouch. You know, I would say when you're talking about 300 frames and it's off by 10 frames, like whatever, but that 3D Vcache part, I mean, going all the way up to 360 frames, that is definitely an appreciable difference. So, yeah, Intel is not, you know, I don't think they're also claiming like, oh, hey, you know, like this is amazing. We're all of a sudden, you know, have this secret Vcache sauce to catch up. But I mean, there is an improvement. There is an improvement for sure. Moving over to Tom Clancy's Rainbow Six Siege, there's an improvement there as well. I was actually going to run CS:GO, but that is no longer there anymore. Now it's Counter-Strike 2, and I was worried that the canned benchmark that Gordon typically runs does not work in the new one, and there's no way to go back and use it on the old one.
I didn't even think about their strategy of replacing Go with 2, throwing the benchmark industry into upheaval, but I guess they did.
I've seen some people run tests, and it's probably not that different. But also, I think, and maybe something for a lot of people might not realize, one of the reasons why we do testing on older games is because these games are less likely to have huge improvements. Because when I'm doing the testing, most of these other versions are locked in place, but if this is on Steam, like, you know, I can't run these without an internet connection, and sometimes it just pulls an update, and I don't want the update to be something that's going to devastate the numbers. So yeah, that's one of the reasons why we use older games, and CS:GO 2 is literally brand new, and I've heard that they're patching it plenty. So I was like, you know what? I'm not even going to mess with that. So Rainbow Six Siege is kind of that stand-in for that. We do see a little bit of a bump with the X3D part, but I mean, for the most part, they're all doing damn good. But technically, the 14th gen is a little bit faster.
By a hair.
Yeah, by the. I mean, hey, bigger bar better. Gordon likes to say bigger bar better.
Right.
That number is on top. It won. Next up is I've got an interesting story here. Total War Warhammer 3 is actually an Intel sponsored game. So they actually also did have it in their benchmark reviewer's guide. In the reviewer's guide, they were like, oh man, we see this huge uplift over any of the AMD parts. But what happens in Total War Warhammer 3 is that actually there's multiple benchmarks you can run in here. These are just two of them. I ran Battle and Campaign. Battle, as you can see by the numbers here, Battle is an interesting one because it has a lot of physics going on.
Sure.
And you're actually, I've noticed some serious run-to-run variants on the actual like physics that are played out in there. So the Battle one, that's why you're kind of seeing it all over the place a little bit.
It's just chaos asserting itself.
Yeah, but generally it does
no
like
pun intended.
yeah, hey. Generally it does like a more Vcache. We're seeing it here. Switching over to the Campaign, which I believe is what Intel used in their marketing material. And yes, in the Campaign benchmark, you're definitely seeing a healthy increase for Intel parts over AMD parts, even that 3D Vcache part. And between 14th and 13th gen, it is 14th gen is a little bit faster.
Sure, just a tad. Yeah.
So, moving over to Watch Dogs Legion, this is another example where, man, that 3D Vcache part, it just, when a game loves it, it just loves it. And technically, in 14th gen does better than 13th gen, but not enough to really overcome that Vcache part. And then I also did the Final Fantasy XIV benchmark. This is running in DX11 with maximum settings. This is kind of interesting a little bit where the at 4K, because I ran it both at 1080p and 4K. At 4K, it's actually Intel and AMD are neck and neck, or I should say the Vcache part specifically is neck and neck with both of the Intel chips. But at 4K, the non-3D Vcache part, the Ryzen 9, actually performed worse than both of them. But looking at 1080p, which usually stresses the CPU more and has more of a CPU bottleneck, it catches up to the Intel parts. I'm not quite sure why there's that disparity there. You can definitely see with that trend that no matter what, it does like Vcache, because both of them step up with the Vcache part. But yeah, at 4K, I did not expect that non-X3D part to
you would really think the
drop
graphics
down.
card would be the limiting factor there.
Yeah, so I don't know a ton about what this benchmark runs. I can maybe dig into it, but yeah. So yeah, but I did want to get a 4K example in here. I also, just for shits and giggles, I decided to load up Cyberpunk with the RT Overdrive preset, but I did not run it with any sort of frame generation or upscaling. This is literally just trying to brute force it.
You want these numbers to be pure.
Well, I mean, the argument, so when Gordon runs it, he actually does use upscaling in frame generation, because at that point it's taking some of the load off of the GPU, and it's probably going to put more in the CPU.
Oh, that's fair. Yeah.
I think we would see a little bit more of a differentiation here, but I decided not to. And yeah, I was just like, oh, okay, well, it's pretty much all the same at that point. I thought maybe just because of the RT Overdrive, it would have more stress on the CPU, regardless of if you were upscaling or not, but I'm not seeing that in these numbers specifically.
I'm curious about the benchmarking utility of these kind of path tracing modes that we're seeing pop up a little more regularly now. I'm no graphics engineer, somebody who's more versed in the field can speak to this, but I've kind of understood that this level of ray tracing does hit the CPU pretty hard. Granted, obviously the ray tracing math is happening on the GPU, but building up the BVH and the sorts of things you need the data structures to do ray tracing, I think is also a pretty CPU dependent thing. So I wonder how much this is going to be a thing in benchmarking So
Well-
really kind of a whole system stress test going forward.
And I've heard that as well, and that's why I was like, oh, you know what? I'm just going to run it with no upscaling and no frame gen, stuff like that, just to see. And I once again, I was surprised that we're not seeing like a huge delta between any of these. But yeah, I from what I understand, it is more CPU intensive as well. So we're just not seeing it here. Maybe if I ran the test in a different way, it would have different results. I'm sure Cyberpunk's going to be in plenty of other videos, so definitely go watch that. And I mean, that's the hard part when it comes to this game stuff, is that like there are thousands and thousands of games
Tell me
on the
about
store, right? Like you literally play so many a week, even, that it's just like it for me. It is hard to care too much about the CPU when it comes to gaming. You know, generally there's some advice to be like, oh, okay, you know, like esports type of titles that, you know, like can really benefit from that single threaded is going to see a bump over AMD parts. But also, hey, you know what? A lot of times there's games that come out that just love Vcache. Do we know ahead of time which games love Vcache? I don't, or at least have you ever heard of like, oh, hey, you know what? Like, it runs on Unreal, so it's really going to love Vcache.
Not really, no. Like the one exception to that is stuff like Factorio that's like very simulation heavy, but that's like its own thing for
True.
very dedicated strategy players, let's say, over here off to the side. But in terms of the mainstream, you know, 3D engines, like your Unreals and Unities and stuff like that, like not really. There doesn't seem to be a huge preference there.
Like I wonder if we will ever get to that point where it's like, hey, if you know that a game is made in this engine, you know it's gonna like Vcache, or you know, oh hey, kind of the way we do with like esports titles, usually like higher clock speeds, right? So that's why it's like, for the most part, I would say like, hey, you know what, all things are mostly equal depending on the game, and might as well just go with the Vcache part, because you know maybe you'll get a benefit here and there that's just like, wow, that's a huge benefit. But it's also just like there's so many games out there, and it really just depends on the game that you're playing.
Yeah.
But then also the games that are coming up, and like that's why it's just like, for me, like game testing on CPU stuff, while it does matter and it is important, like I don't know, part of me like stares in the distance and be like, I mean, I guess I could benchmark all these games, but no, I don't got the time to do all that. So, yeah, I'd leave that to other people on YouTube. Okay, so that's all the game stuff. There's one last section to get into before we kind of wrap it up here, and that's power. So I talked a little bit about the power delivery and how we kind of set things up here for most of this testing. And so I'm going to go over how things were configured, you know, the way we did it here. So this is a logging watt meter. I ran it into a program. Gordon had to show me how to use it because I had never used it before, but it's essentially taking timestamps at various parts in a Cinebench run. This one specifically is for single core, and kind of showing the power delta between the two. This is specifically between the 14900K and the 7950X. And as you can see, interestingly enough, the Core i9 uses less wattage. We're talking about about 170 at that like flattest part of the AMD, versus 148 at like the flattest part of the Intel chip. So you know, a little bit of a power savings, but also Intel like finishes quicker. And turns in a better score. So
I have to tell you, I suppressed a gasp when you revealed this page.
Oh, really?
Quite frankly, because
you thought AMD was gonna be better at the single core.
I mean, like power consumption and heat and et cetera, was one of the. It was kind of the basis on which I made my choice between AMD and Intel earlier this year, or one of them, one of the primary considerations. And at that time, I think it was the case that AMD was ahead. So I'm duly impressed here that Intel seems to have.
Well, wait. I think
Okay,
I think you're
benchmark.
thinking of, but also I think you're thinking of multi-core workloads.
Well, sure.
Yeah.
Sure.
So like
This is single core. Yes.
Single core, we're literally talking
Okay.
about big performance core versus
Yes.
big performance
Yes.
core. Actually, Intel has always had just a
You're
slight
right.
advantage
You're
that
right.
way.
You're right.
I mean, in the grand scheme of things, we're talking about, you know, like 20 watts.
Yeah, not huge.
Yeah, not huge. I will say, compared to the 13900K, it is actually using 10 more watts in this same scenario. So it is driving a little bit more power.
I see. Okay.
And that's how it's getting the bigger number on the
So
slide.
I'm jumping the gun here. just a little bit.
Yeah. But if we switch over to multi-core performance,
There's the graph
That's-
that's more familiar.
that is what you're thinking of. So this chart is once again the 14900K, which is the lines on top, and then versus the 7950X, which is the chart kind of on bottom. If we look at just those little plateaus, which each one of those is a Cinebench run, multi-cores spiking up and going over and over again. If you look at those little plateaus, Intel is about 423 watts, where the AMD is about 375 watts. The other difference that you see is that for AMD, you're not seeing those huge spikes at the beginning of every run. So Intel definitely has these like little boosts that go up, and the highest one that I kind of recorded here was about 534 watts at the very beginning as it burned off that like really initial boost. So yeah, Intel kind of like boosts up for a quick second, levels off, finishes. Boosts up for a quick second, where AMD is just like, it goes up to where it goes, down, up to where it goes, down. So once again, it did, you know, use less power, and by the course of that, it's going to generate more heat. And if we go back to the original chart for the actual score, it was pretty much dead even. So yes, under multi-core workload, the AMD system is definitely doing better than the Intel, and that has not changed compared to 13th gen. But the 13th gen, if we compare that number in here, this is the 13th gen versus the X3D part. The 13th gen actually plateaued at about 462 watts. So compare that to the 423 watts. And I'll say the number was pretty much even for the score, but it's actually using about 40 less watts.
Sure.
So, okay.
Yeah,
That's not bad.
if it's lower where it's spending 90% of its time, that's
Right,
yeah,
right.
That's something.
Yeah. And then, the last thing to kind of show off is that unleashed mode, where the ICC max is at 400 amps, and it's just really like go all the way. So Intel doesn't call it unleashed. Is actually in the Gigabyte BIOS. There's a little switch where you just switch it, and it says unleashed. Gigabyte has a little warning that says, hey, you know what? If you're going to do this, you should at least have a 420 or 480 millimeter rad, which actually I didn't. I just had 360. So when we go into unleashed mode, here's the power.
Oh my.
It spikes all the way up to, at that highest point, about 560 watts.
Wow.
So that is about, you know, over 100 more watts than the optimized profile that I was
Yeah.
running earlier.
And the sustained power usage looks like it's just over 500 here.
Yeah. So then when it finally, you know, like kind of, for lack of a better term, cools off that boost, when it hits those plateaus, it's hitting about 500 watts.
Cool being a very relative term here.
Right. So, but still, that's about 80 watts over the actual default setup that I had. So I'm going to ask you right now, do you think Unleashed mode turned in a better multi-core score?
I should hope so.
There is the Unleashed number.
Okay then. All right. Well, it's your power bill, I guess.
So I will say once again, if it's recommended to have a 420 millimeter or 480 millimeter rad, I did not have that on there, so maybe you will get more of a boost. I will also say in the way Cinebench defaults is to a single run. This is over a 10-minute loop with 3 back-to-back runs, an average number. So yes, when I just did one run, I was seeing over 38,000 points. So definitely was getting more.
In a bursty kind of fashion.
In a bursty kind of fashion,
Yeah.
yes. But the way that we did the test here, because it's a 10-minute loop, it kind of negated that. And at the end of the day, you're just talking about a lot of heat, a lot of power being used.
Yeah.
But hey, you know what? Somebody might want that. There's definitely somebody out there that I think could be like, hey, you know what? Give me as much power as you can. And you know who that person is? That person's Gordon. So yeah,
the man likes what he likes.
he does. He likes bigger bar better. He likes drag racing, right?
I will tell you though, even on the 7950 X3D with a 4090, you know that is a chip that uses less power generally on average. There's not only the heat inside the case, the heat dissipation for the health of the components aspect of it.
Yeah.
There's also increasingly a little bit of a room comfort conversation to have here, where even that thing, when I'm playing a game for more than 30 minutes, starts functioning like a space heater. So every little bit really matters, I think, in a real world setting with this stuff.
And I mean, the way I tested here, I'm in a controlled, cooled environment. You know, I have all the case panels off, so you know it's getting as much of that natural airflow that it is. So yeah, you throw one of these in a normal case, obviously it's going to perform different. But the way we like to test it is this way. Yeah, I mean generally for me, I definitely care more about the heat that it's spewing on the side as well than somebody like Gordon. The power bill, and hey, our friends in Europe definitely have a lot of power bill considerations to look into. We don't care too much about it over here in the U.S., some of us. So, you know, but I care more about the heat being spewed out, and yeah.
It is a consideration. The first time my significant other walked in the room after I got this new machine and just said, God, why is it so hot in here? I was like, yeah, maybe these things are a little out of control.
You know, you should try eco mode. I'm surprised.
I should. I have put it off, but I should probably.
So
at the same time, I talk all this talk, but I do need the frames.
Right, you get to take the frames. And I will say, like, there's definitely a lot of stuff about power in the reviewer's guide, saying like, hey, you know, it is pound for pound using less power than 13th gen and turning in the same performance. So that is awesome. I mean, it's still using more than AMD, but hey, it's at least the efficiencies they've gotten in this refreshed chip is better. There are a couple other things that I do want to mention that I wasn't able to test. Intel has this new thing called Intel Application Optimization. So I'm going to talk about this in kind of a weird way because I actually don't fully know the details because we don't have it. We weren't able to test it, and during the briefing we were able to ask some questions, but it was also kind of nebulous, and we're not really going to be able to tell until we get our hands on it. They're saying with just running this application, it's going to be able to see that you're running that application, and it knows that, hey, we know what we can actually boost a little bit higher in these. So Metro Exodus are saying they're getting 16% more frames. Rainbow Six Siege 13% more frames. We don't know how many frames that is. That's just a percentage. So hopefully testing will tell. But the idea is like, hey, there is even more performance maybe to come out of these 14 gen parts. We just don't know yet. The application is not out yet, and I don't know how wide ranging it's going to be, but it could be maybe, to give them benefit of the doubt, it could be like one of those situations like the 3D V-Cache where it's like, hey, you know what, certain applications that are whitelisted, it's all of a sudden just going to get this huge benefit and you don't need to do anything specific. I don't know if it's going to work like that, but hey, maybe it could, and that would be really cool.
Have they said that that's just for games, or is that something that could apply to different productivity type stuff as well?
So looking at the slide, it says software optimizations focused on gaming applications. Okay. And the other thing that I didn't get to mess with was in XTU, an update to XTU, they're going to have AI overclocking. Do you like AI?
That's a thorny topic. Sure, in some contexts.
What if AI overclocked your CPU?
What if AI just ran everything? I don't know.
So in XTU, you've been able to run a specialized overclocking. Essentially be like, tell me what you think I should overclock it to, right? So that's nothing new, but what they're saying with this new version of XTU, and I haven't had a chance to play with it, but they've been able to train a bunch of systems in their labs to say, hey, you know what? With AI, the power of AI, we can overclock the CPU a little bit better than it's been able to in the past.
That sounds like a good application of the technology for sure.
Yeah. So once again, I haven't played with it. I have no idea, but I will say, and I did ask this directly during the briefing, this is only going to be on 14th gen parts, and assuming going forward as well, if this is something that they continue to support. And they say because like the amount of things that they'd have to spin up with older generations, it would just take too much time.
Sure.
Okay.
This probably betrays my ignorance of XTU. Is that something that runs just at the BIOS or UEFI level, or is that something in Windows as well?
XTU is an application in Windows, so it's like Ryzen Master on the AMD side. So yeah, I've used it before, and actually, I mean, I've used it more for undervolting.
Yeah.
And honestly, like, I haven't done any undervolting tests, but I actually think that these parts are gonna do well with an undervolt. I know my 13900K on my editing rig definitely did much better with an undervolt.
Sure.
So yeah, I wish they had AI assist for undervolting. Maybe that's next Intel. But let's wrap it up. To kind of give a conclusion, and I did talk to Gordon before we filmed this video, so I kind of got his thoughts on there, and we're in lockstep. I mean, I think there's a couple takeaways. Obviously, the 13900KS came out earlier, and a lot of people were saying, oh my god, it's so expensive and it's so power hungry, and just to get to 1st to 6 gigahertz. One of the ways to think about this is that the 14900K is a cheaper and cooler mass market 13900KS.
6 gigahertz kind of for everyone now. I mean, not to say that a K is necessarily a mainstream part. I mean, it's more mainstream certainly than a KS, but it's guaranteed if you want to hit 6 gigahertz.
And like I said, I was definitely watching it every once in a while just to double check, and it had no problem hitting 6 gigahertz with the setup that I had. Maybe your situation is going to be a little bit different based off your cooling and things like that, but yeah, it was hitting 6 gigahertz all day, and using less power to do it. I mean, not only was it using less power than the 13900K, it was definitely using less power than the 13900KS. Even though I didn't test a KS part, like I can guarantee you that it's using less power than a KS part. so that's one way to look at it. And yeah, so it's cheaper. MSRP is pretty much the same with 13900K. 13900K on Newegg can be found a little bit cheaper right now. I'm recording this before embargo, so prices are going to fluctuate. But hey, if you ever looked at a KS and you were like, oh man, I wish I could have a KS, but it's too hot and it's too expensive, then okay, this kind of slots back in with that. Another way to look at it, and this is kind of coming from Gordon, is that it's got that new car smell. Like you can't roll into 2024 next year with 13th gen, right? No, you get 14th gen. Yeah, right. So like, hey, every company has financial considerations. They want to get some new stuff out. Obviously, Meteor Lake and for a socketed desktop part, and Arrow Lake is not ready. Mm-hmm. I'm sure they would love it to be ready, but in the meantime, they're able to get some efficiencies out of Raptor Lake, and so they felt the need to put out this 14th gen part. I mean, maybe there's some people who are like, oh, that's stupid, just release Arrow Lake. Well, okay, it's not ready yet. Yeah. So would you rather have them continue with just 13th gen until Arrow Lake, which we don't know when that's going to come out, or kind of come in and refresh and be like, hey, you know what? Sure, it's more of the same. But there are some benefits here and there, and if you're in as a new buyer looking into it, then you get some benefit out of it.
That very much seems like the theme here. Like if you're in the market for a new system and you want to go Intel, this is the thing to get because this is the new thing, right?
Yeah.
Like it is better. It's very marginal. I mean, is 14th gen an upgrade over 13th gen? Like never has a question been less necessary in the history of computers.
Yeah, no. If you're on 13th gen, well, I mean. Line for line, right? If you're already on a 13900K, no.
Yes.
Yeah. Right? Yeah. But hey, I mean the other thing that I wanted to do was test Alder Lake. Unfortunately, I didn't have time to do it. But I mean, if you think about it, we got 3 chips on the same socket. If you were somebody who got in early on with Alder Lake 12th gen, and you had like maybe an i5, and you have all these other options to look into. That's better, right? To be able to upgrade. I know a lot of people don't necessarily do drop-in upgrades, but it's all the rage with AMD.
Sure.
So while technically I know some people are going to argue this is not a real generation, this is just a refresh. Yes, I can agree with you, right? And I totally understand that. But also, I would like to give credit to Intel. This is three product cycles in one socket, and I would like to see more of that, please, Intel. I understand that they've always said, hey, you know what? We'd love to push the bleeding edge of the technology, the new chipset, the new PCIe lanes, the Gen 5 drives, and all that stuff. But I feel like we're to a good spot where we don't need to necessarily push it, and we can hopefully get more generations out of the same socket, like AMD has been able to do. So, while this isn't necessarily a new generation, and it's nothing drastic, it's at least a new generation in the same socket.
Is it maybe it's too early to ask this, or there are too many boards out there to say definitively, but is it pretty widely supported that you could drop a 14th gen chip into like a Z690 board? Pretty.
I mean, that's
pretty much across the board.
I mean, I think so Z690 is a different chipset, so you are gonna lose out on some of the
Sure.
benefits of that.
Sure.
But yes, it should be able to. I haven't tested it, but you should be able to drop it in and get the benefits from that. So while we wait for whatever is cooking up next on Intel's desktop, most likely it's going to be Arrow Lake sometime in 2024. Rumors say maybe later 2024 than earlier. I don't know. I've not looked too far into it. And who knows what that's going to bring, but that will be definitely a generational change, which
it's a huge transition. I mean, you were kind enough to come on the Tech Pod recently with Will and I and tell us about it. But it
for
is
Meteor Lake, yeah,
it is right. It's the biggest transition for Intel since since they went to the Core architecture. I mean, it's like unsurprising that it's going to take a little extra time to iron out this basically entire new paradigm of CPU design for them. Obviously, AMD has been in this space for a little while, but it's hard to fault them.
It's different. I mean, but also it's like I think about this in gaming too. Like, take your time. Would you rather have a game come out buggy, or would you rather have the developer be like, hey, you know what? We're gonna delay it a year to iron out some stuff.
Yes.
Me personally, take your time.
I mean, hey, I don't even have to go to a gaming example. I can tell you from the computing world, being on a fairly brand new platform, get it right, make sure it works.
Take your time. So yeah, like I'm not chomping at the bit. And, I also feel like we're at a wealth of riches with all this stuff nowadays on the CPU side.
Yeah.
That
computers are not exactly slow. These days.
Yeah. But luckily for me, at least, 14th gen just being a refresh part. I will say this. I've said it before to Gordon. Like this, as it being my first CPU review, I kind of dubbed it as like baby's first CPU review, because this is just a refresh part. I didn't have to worry about like crazy beta BIOSes or having to understand any crazy new features.
Probably the least unknowns you could have going into a review like this, I'm sure.
Yeah, and being able to drop older generation chips and not have like different motherboards is, was definitely like, oh, okay, I was able to chomp my teeth into this one, and it lower stakes than usual, for lack of a better term. So I was once again happy to be able to fill in for Gordon while he's on medical leave. But I do want to test more CPUs, and I've even been helping Brad Charkis test GPUs every once in a while as well. So like this testing stuff, I feel like I've got a hunger for it, and I want to keep going. So, anyway, thanks to everybody for watching. Thank you to Gordon so much. I can't say this again. Thank you so much for mentoring me and helping me through the harrowing review cycle of this. He knows it, obviously more than the rest of us, but for me to go through it the first time, it felt really good to have him kind of have my back. For sure, and especially people like Steve and Ian as well, and all the fine folks at AMD and Intel and all the vendors and things like that. And thank you to you for coming in. I was like, you know what, I would rather have somebody to sit down and chat with this stuff about than just like stare at the camera and regurgitate my thoughts, because I'm kind of tired and loopy anyway.
A lot of numbers going through the brain, I'm sure.
A lot of numbers, a lot of charts, a lot of double checking, like, oh crap, did I set it right? Anyway, I definitely have almost all the numbers for the i7, just not ready for the launch. that will be coming up, and then I'm going to move on to the i5. The i7, I can tell you just from having some of the numbers, that is a little bit more than just a refresh because it has 4 extra E-cores.
Oh.
So you're getting the clock bump, the power savings, and the 4 extra E-cores. And so just a little spoiler, that is definitely the one to be a little bit excited about.
Sounding like a price to performance winner, perhaps.
Perhaps. We will see in the review. So if you want to watch that, be sure to subscribe here on PCWorld.com. And Brad, should they go over to Twitch? Or I guess you have a YouTube channel as well for Nextlander.
Yeah, Nextlander.com points to our Patreon, which has links to all of our Twitch and YouTube and podcasts and stuff. So Nextlander.com for all of my video game stuff.
There you go.
And techpod.content.town for the Tech Pod.
Yeah, you know what? You should just do CPU reviews all the time for the gaming side. You handle that, and I don't got to worry about it.
Video game reviews were one thing.
Okay.
Like, this seems like a lot.
It is a lot. Anyway, thank you everybody, and we will catch you in the next one. Bye.